Hello friends, today we will going to study the topic code generation issues in the design of code generation. So code generation, as we know, this slide contains the diagram for the code generation in which the source program is given as an input for the front end which can generate the intermediate code. Then the intermediate code is given to the code optimization which optimizer which can use the symbol table and generate the intermediate code with the optimization. Then that time that code with the optimization is given to the code generator to find out the target code. So this code generation is nothing but the final phase of the compiler model, and it will take the input from the intermediate representation with a code optimization. And this technique can be used whether or not the optimization phase occur before code generation. Okay, so this code generation phase or the code is generated by the compiler is an object code of the lower level of the programming language, for example, assembly language. Then we have to see that the source code written in a high level of the language is transferred into the low level of the language that result into the lower level object code, which should be have the following minimum property, that is nothing but that code is exact, carry the exact meaning as that of the source code. After that it should be efficient in terms of the CPU uses and memory management, and we will now see how the intermediate code is transferred to the target assembly code. So under this code generation, there are the three primary tasks are there: instruction selection, register allocation and assignment, and instruction ordering. Under the instruction selection, we can select the proper instruction for representing the code. After that, register allocation and the assignment contain the allocating the different types of the register for the particular operation and assignment of that operation to the register. And instruction ordering is nothing but as per the preference the instruction is ordered for the execution. So code generation content basically generate the code by using the following things. So it contains the target language, after that intermediate representation type, then selection of instruction, register allocation, ordering of instruction. So under that, target language is nothing but as we code generation has to be aware of the nature of the target language for which the code is to be transformed. That language may facilitate some machine-specific instruction to help the compiler to generate the code in a more convenient way. So this target machine can have the CISC or the RISC processor architecture for generating the target language. After that, intermediate representation type contain the various forms which can also contain the syntax tree or abstract syntax tree format. So this syntax tree is generated from the parse tree, and abstract syntax tree is nothing but the abstract form of that of the syntax tree. It also contains the reverse Polish notation and three address code. Selection of the instruction. Selection of the instruction is nothing but it takes the intermediate representation as an input and convert or map that intermediate representation into the target machine instruction set. So one representation can have the many instructions to convert it. So in this way, the code generator can choose the appropriate instruction wisely. After that, register allocation. So the program has number of values and that value are maintained during the execution. So target machine architecture may not allow all that value to keep into the CPU memory or the register. So that's why the code generator decides to keep that value in a register and also keep value for the further operation. Ordering of instruction is nothing but giving the order to that instruction as per the need of execution or as per the preference, and prepare schedule for execution of that instruction. So in this way, the code generator is expected to have understanding of the target machine runtime environment and its instruction set. The code generation should take the following things into the consideration whenever generate the code. First one is nothing but the target language, second one is nothing but the intermediate representation type, then selection of instruction, register allocation, and ordering of instruction. Now we turn to the main design issue of a code generation. So code generation phases, there are the various issues. First issue is nothing but the input to the code generator. Second one is the target program. Third one is the memory management. Fourth one is the instruction selection. Fifth one is the register allocation. And sixth one is the evaluation order. First is nothing but the input to the code generator. As the intermediate representation having the many choices. Like the intermediate representation may be using the postfix notation or syntax tree or a three address code. So as per that, we can give the input to the code generator. Either that particular input contain the representation of the postfix notation, syntax tree or three address code, and all that representation from the front end produces the low level intermediate representation. That is nothing but the value of the names in it can directly manipulated by the machine instruction. Second one is the target program. So target program is nothing but the output of that code generator, and that output is in the assembly language, relocatable machine language, or the absolute machine language. When it is represented as a asynchronous language, it allows the subprograms to separately compile. When the target program is in the locatable machine language, then it makes the process of the code generation easier. And when that representation is into the absolute machine language, then that time it can be placed in a fixed location in the memory and can be executed immediately. Third one is nothing but the memory management. So what is done under the memory management? As the name suggests, memory management provides the space for each and every variables or the value present into the program. So how that particular labeling or the spacing is takes place? So equal names in a source program are mapped by the addresses into the data object in a runtime memory by the front end and the code generation. After that, all that is stored into the symbol table. Then the name and the address refer into the symbol table entries for the name. After that, the labels in the three address statement have to be converted to the address of the instruction. For example, I shown it to the slide. Just consider the example J is equal to go to I generate jump instruction is as follows. Here we have to find out where I is less than j or I is greater than j. If I is less than j, then that type backward jump instruction with the target address equal to the location of the code for the quadruple is generated. And if I is greater than j, then that time jump is the forward. That means the list of the quadruple I location or of the first machine instruction generated for the quadruple j. So in this way, the memory management is takes place. After that, instruction selection. So how the instructions are selected for converting that particular code or for the code generation is nothing but the instruction of the target machine should be complete and uniform. Instruction speed and machine idleness are important factor when the efficiency of a target machine is considered. After that, the quality of generated code is also determined the speed and size of that particular code. So that statement is represented in the following manner. So instruction selection example is here. So one example A is equal to B plus B, B plus C, B is equal to A plus B into bracket. This instruction is represented in instruction selection as a example shows. Just consider this slide. After that, register allocation. Register allocation is nothing but allocating the particular variable value for the particular register. So this is nothing but a set of the variables that will reside in that particular register at the point in the program is selected. So the use of register is subdivided into the two subproblems, namely the register allocation and register assignment. So register allocation is different and register assignment is different. Allocation is nothing but that variable will reside into that particular register point. And register assignment is nothing but the specific register value is big. After that, it also contains a certain machine require even not register here. for the operands and result. For that time, we can consider the division instruction of the form d of x, y, where x is nothing but the dividend and y is nothing but the divisor. Even register holds the remainder, where the odd register holds the quotient. In this way, we represent the register allocation. After that, the sixth point is design issue is nothing but the evaluation order. So that order is affect the efficiency of the target code. Some computation order require the fewer registers to hold the intermediate registers and overlay. So in this way, we have to study different type of the design issue for the code generation.